Hello everyone, this is Arohi and welcome to my channel. So guys, in this video I'll show you how to perform object tracking on custom dataset using YOLOv8 and different object tracking algorithms. So whenever we say tracking, that means there are series of steps which you have to follow to make your custom object tracker. Okay, so first thing is detection. So what we does is first we detect the object in a frame, and then we keep on knowing the position of that object in the next frames, and we uniquely identify them by providing a different ID to them, and we keep on tracking them until that object leaves the frame. Okay, so for this whole functionality, for this whole work which I've just told you, what we does is there are three steps which we follow. First is object detection. Object detection, what we are going to do today, first we will create our object detector to detect our custom object, and then second thing is to create a feature extractor model. Why we need this feature extractor model? Because when we use Kalman filter track the object on the basis of velocity and the motion of that object. Okay, so with Kalman filter sometimes we face a problems of if occlusion is there or ID switching problem, right? These kind of problems we cannot solve these problems fully with Kalman filter. Okay, so for that we will use a feature extractor also. This feature extractor will help us knowing the appearance of that object. Okay, so we need a feature extractor model which will help us knowing the appearance of the object. We will use Kalman filter because on the basis of velocity and motion of that object we'll track the object. We'll use object detection model to detect the object first. First we detect the object and then we use feature extractor and Kalman filter on it, and then our tracker will be ready. Okay, so let's start for today's class. So initially let's start with the dataset. First let's see which custom class we are working upon and how to prepare that dataset. So guys, I'm starting with the feature extractor first. I'll show you how to create a dataset for your feature extractor to work on custom class. So let's start. So for that, okay, here you can see I have two folders, train and val folder. Okay, inside a train folder you can see I have these different folder, boat 1, boat 2, boat 3. So what I'm doing is for today's class I'm working on a single custom class, and that class is boats. We are going to track the boats. Okay, so let's open the first folder and have different images of boats, and every image, okay, let me open it. So I have cropped the image from the area where that object is actually present. So this is the image with crop. Okay, now let me show you how it looked before cropping. Okay, let it get open. So I'm just showing you the example. This is a different image. So you can see this is your image before cropping. This is the image of a boat, but you need to crop the image from the area where your object is actually present. Okay, so this is what I have done here. For every class here you can see I have cropped the image where the object is actually present. And guys, you can also see here, one thing to note here is, see, when we work on object detection model, how we prepare dataset, we just randomly collect. Suppose you want to create an object detection model which can detect boats. What you will do? You will collect the random images from internet and you will mark the area where your object is actually present, and there is no need that all the images of your dataset to be related. Okay, we just collect random images, we mark the areas, we annotate the area where our image is, and that's what we do. Okay, but over here you will see that inside one folder I have images which belongs to one boat class. So what you can do is just download the video of the class which you want to detect. Suppose you want to work on a table class. Okay, so just download a table video of a table from internet and save the different frames of that table video in one folder and give it a one ID. So in my case, boat 0 is a class name, label name for the board frames which are present in this folder, and you have to crop them. Now let's open another folder. Now let's see what is there in board 2. If you'll open board 2, here you can see I have a different board, but all the images in this folder belongs to a single board only. Okay, and this is how you need to prepare your data set. Okay, so on this data set we are going to train our feature extractor, and in the same way guys, you can see I have data of 53 different boards. Okay, I have data of 53 different boards and I have cropped the area where the object is actually present. So this is how you have to prepare the data. And in the same way, let's open a val folder. Now guys, in the val folder also you need the exact same classes which are present in your train folder. So in your train folder you can see these kind of folders we have, and exactly 53 different board classes were there in my train folder. So in the same way 53 different classes are there in my validation folder also. And when you open these folder, now this time, okay, so this is a mistake. Here you can see this time in validation folder we have less number of frames. While training we are using more frames because we want to train our algorithm to know the features of it, and over here this data is for validation, so I'm using less number of frames. Okay, so this is how you have to prepare your data. Okay, so this data set will go to the feature extractor model. Now guys, for feature extraction what you can do is, see, whenever you have studied about image classification, so over there you know that we extract the features and then we finally have a dense layer, and after that we have over there we perform the classification. Okay, so you can create your own feature extractor, and that feature extractor model should be a PyTorch model. Okay, so you can take help from the PyTorch official website. There they have shown how to create your feature extractor model and how to fine tune your model. So from there you can see that how to use your own feature extractor. Okay, I'll just show you way how I implemented it. Okay, so in this folder I have this feature extractor. So for initially I'm importing all the required modules, and then here I'm loading the dataset. Okay, I'm loading the dataset, I'm performing data augmentation on it, I'm normalizing those images because that will help you will get better results with it. So that's what I'm doing. So this is for my train folder, this is for my validation folder, this is the dataset directory. Now my dataset directory name is dataset. So let me show you this. See, this is the code I have, and this is the dataset folder. Under this dataset folder I have a train and validation folder. Inside train I have the folders to train the algorithm, and inside validation I have the validation images. Okay, so here, so right, once your dataset is prepared, I am training the model. This is the function which I have created for training the model. Okay, this function will train your algorithm. And guys, again, this function, I picked this function from the PyTorch official website, okay, for training our algorithm. And then over here I'm using that model as a feature extractor. So what you need to do is you just need to take care of this should be false. Okay, so if you want to use your model as a feature extractor, then this should be a false over here. Okay, and then here I'm training my algorithm, and I'm training the algorithm for 25 epochs, and my model training is going on this variable. And after that, once training is done, I am saving that model. See, model variable is carrying the training details. So I'm saving it with this name. So now we have a feature extractor model, this, and let's visualize some predictions. Let's see if our model is trained properly or not. Okay, so for that, this function I have created, this will show us the predictions. Okay, so yeah, over here you can see this feature is a part of board 51. This is the prediction, and this feature is a part of board 5. So let's see, let's open the board 5 and see if we have these kind of image features in that. Okay, so board 5, let's open that, dataset, train, board 5, and yes, you can see this is the board 5 and the feature which we have is this. Okay, so this is, look, this is a part of board 5. All right, so in the same way, let's see board 30. This is belongs to board 30 as per our model. So let's open board 30 and see if we have these kind of features in that. So let's open board 30, and yes, you can see we have this board and the feature we have is this. So yes, this belongs to that class. So our feature extractor model is ready, right? It's working fine. So let's do the next functionality. One model is ready now. This model we will provide this model to our tracking algorithm. This algorithm, this feature extractor will help the tracker to know the appearance of the object. Okay, so one part is done. Okay, so here you have a feature extractor model. Okay, now the next thing is object detection. We need to build our object detector on our custom dataset now, and our custom class is board. Okay, so for that we are using YOLOv8 to train our algorithm. Okay, so let me open the notebook over here. So this is the third part, board detection. Let's open this Jupyter notebook. See guys, it's very simple. What I've done is just import. So for this you need a YOLOv8, and you can install YOLOv8 but by just writing pip install Ultralytics, and your YOLOv8 environment will be ready. After that you just need to run this and your training will be done. So what I'm doing is importing the YOLO and uncommented. What I'm doing is model.train. I want to train the model, and I'm providing this data.yaml. Now what is this data.yaml? Let's see that. So this is my data.yaml file. So number of classes are 1, and this is the class name, board underscore ship underscore yacht. Okay, so I have used the images of boards, ship and yacht, and I considered it as a one class, and this is how your data.yml file will look like. And now let me show you the dataset. This is the dataset for training the object detection model, and inside it we have a train and valid folder. Inside train we have images, and inside labels we have a annotation files which are in text format. And guys, how YOLO accepts a dataset, for every image we have a different text file, and in that text file we have the annotation detail of the image. Okay, so inside images you can see we have all the images. So I have used 634 different images to train the custom object detection model. Okay, so this is my dataset, and I have shown you my dataset data.yml file also. So once your training done, you will see, okay, inside this you will have the details, and inside this weights you will have this best.pt. So this model will be given to the object tracker to detect the objects, because whenever we want to track the object, what we do, we detect the object and for detecting the object we are using YOLOv8. This model will be helping the tracker model for detecting the objects. And then we have a feature extractor model. That model will help the tracker to know the appearance of the object. Okay, so that part done, and the object detection part is also done now. And now, okay, if you want to see the output, let me show you. So this is how it is detecting the boat, ship and yacht class. Okay, so our YOLOv8 model is ready now. Now next part is tracking. So guys, now first for tracking what we will do, I am using I'm picking the code from this GitHub repo. So clone this GitHub repo. Okay, so guys, till now we have done object detection code. You will get those are just 4 lines. Just do install Ultralytics, and these 4 lines you can visit the official GitHub repo of YOLOv8 and you can get the code from here. Okay, and the feature extractor code, I have told you that you can go to the PyTorch official site, and from there you can get the feature extractor code. And the third part is this object tracking code you can get from here. Okay, clone this GitHub repo. How to use it, how to perform it? Just these 3 lines will after executing these 3 lines, your object tracking environment will be ready. Okay, clone the GitHub repo. After cloning the GitHub repo, you will get a YOLOv8 tracking folder. Okay, let me show you that. Inside this I'm doing, so here I cloned the GitHub repo and I have this folder. Okay, inside this folder you will have all the tracking files. Okay, and what you need is, after that, install the dependencies like this. Okay, now let's run the tracker. Now to run the tracker, the command is python track.py. Then you need to provide a YOLOv8. Let me show you from here. Here you can see that tracking here, then this. Okay, so what I have done, python track.py, provide the source. I want to perform the tracking on this video. Okay, if you'll provide source 0, it will open a webcam. If you'll provide if you want to provide a RTSP stream, you can provide here. Then we are using a YOLOv8. Now in YOLOv8, remember we have created a best.pt file, so I have renamed it best_boat. Okay, so this is the model which we got from YOLOv8 object detection, and which was trained on boat. And this weight will be a model that feature extractor. Remember we have created this feature extractor, so we are providing the path of that, and after that we are writing this save video. If you will not write this, then your tracking results will not be stored. So save video flag will save the video, okay, with the trackings. Now let's see the results. Here you can see runs, track, and here let's open this one. So you can see boat, shipyard, and we are getting the percentage over here. This is with the detection, and they have ID. This boat have ship have 1, and over here we have 3. So these are the unique IDs provided by our tracker. Okay, so guys, this is how you can build your own custom object tracker. And I have done till now is, see guys, inside this track.py there are these kind of 3 different tracking methods. Tracking method, strong sort, okay, OC sort, and by track. Okay, so now let's go to our code. Okay, it's here. Here our code. Okay, let's open this track.py file. Here you can see, yeah, here. By tracking method I have used over here is strong sort. Now if you want to use different tracking method like this, suppose you want to use OC sort or byte sort, you can use this flag tracking method. Here you can, let's put here tracking method space and then write the tracking method you want to use. So if you want to use a byte track, just write byte track here. If you want to use strong sort, then you can use that, and if you want to use this tracking method, you can use that. So these are the different tracking method you can use, and you can, under this tracking sources, you can see that source 0 is for web camera and image, video, and if you want to work on RTSP streams, right? So all these sources you can provide like this. So that's it, guys. This is how this object tracking on custom dataset example works. Okay, and if this video is helpful, and please like, share and subscribe my channel. Thank you for watching.